Algebra 2 honors, these are notes for the kitchen sink. These are the last notes for before our first quiz. And I'm actually going to just have a skip the warm-up. Your first 3 problems on your homework are the difference quotient, and you'll have time to get started in class to work on those. So if you are having questions on those, you can get help with those when we get to that. So the first thing we're going to do is we have a graph, and then you're just going to be answering a bunch of questions over those. So when I look at number 1, you need to understand what this means. F of 2. Well, first of all, use the graph of f of x. So this is the graph of f of x. And this means when x is 2, what is y? We don't have an equation to plug into it, but we can just go to the graph, 2 to the right, and we go down 3. And so this ordered pair, 2, negative 3, is on the graph. So f of 2 is negative 3. F of 2 is negative 3 because when x is 2, y is negative 3. Questions on that? So instead of being given an equation, f of x is 3x plus 1, and then what is f of 5, and you plug 5 in for this is, you get it from the graph. It's just a different way to ask it. Then we have the number 2, turning points. And turning points are your relative max or min. Turning points are where the function changes either from increasing to decreasing, or from decreasing to increasing. So you're going up, 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 and then you start coming back down. You have a turning point. You're going down, down, down. You turn to go back up. You have a turning point. So they are ordered pairs. This is a turning point, and this is a turning point. Those are your turning points, here and here. So it's just a matter of writing that ordered pair. So to the left, 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. To the left 4 and up 6. Now, these are not intervals. These are XY ordered pairs. It's in context. You have to understand turning point is an ordered pair. And so there's a second one. We do not use the union symbol. We use a comma between ordered pairs. We use the union symbols on domain, increasing, decreasing, positive, negative for those intervals. But this is an ordered XY pair. We don't do a union symbol. We just do a comma in between them. So then once again, here's your other turning point. Changes from decreasing to increasing. You're to the right 2 and down 1, 2, 3. So it's the ordered pair 2, negative 3. In problem number 3, we see that function notation similar to problem number 1. This f of 6 means what is the y coordinate when x is 6? And we're going to plug in the value for that. So when x is 6, 1, 2, 3, 4, 5, 6, y is 2. So we are going to plug in 2. F of 6 is 2. And this dot means multiplication. So I want to see that the value you got for f of 6 is 2. I don't want just the answer. I want to see that you identified f of 6 is 2. It should be evident in your work. And so then you multiply those, and the answer is 6. Box it. Yesterday's lesson, we worked on average rate of change, and we talked about this is an interval, and both of these are x values. So negative 4 is x sub 1, and 6 is x sub 2. And I want to see the ordered pairs. So I want you to show me the 2 points you're going to use. Average rate of change is simply slope. What points are you going to use? Well, when x is negative 4, we're going to find y on the graph. And when x is 6, we're going to find y on the graph. I want to see those written. And so at negative 4, that's when the y value is up at 6. And when x is 6, you are up 2, so the y value for that is 2. So those are the 2 points, and you're getting those from the graph. And then label it, slope. Change in y, 2 minus 6 over 6 minus a negative 4. Change in x over change in y. And you get a negative 4 over 10. You need to reduce that. So you need to write your final answer as a negative 2/5 and box it. On problem number 5, we are using absolute value. That's what these bars are. Those are absolute value. And what you need to do is you need to simplify what is on the inside first and then take your absolute value. Last year, I think it's just people haven't used absolute value a lot. The absolute value of a negative 5 is 5. The absolute value of 3 is the number itself. The absolute value of 0 is 0. It's just, if a number is negative, you're going to make it positive. What I saw students doing last year that was wrong is they thought, okay, absolute value makes everything positive. Well, they thought they could just get rid of any negative inside and evaluate it, and that's the same thing. And they did this, and that's wrong. You don't just go through and change all negatives inside to positive. You have to first evaluate inside. You need to first combine those, then take the absolute value. So back on the front page, or I was just showing that, what I want to do is show what I get for f of 2, show what I get for f of 4, do the correct order of operations. So f of 2, again, is, we go the right 2 down 3, the y coordinate there is negative 3. F of negative 4, go to the left 4 and up 6, the y coordinate there is 6. And then order of operation, you need to do the multiplication first. And then simplify inside. And then your final answer is 24. So just show your work there like that. I want to be able to see what you substituted in for, f of 2. I want to see what you substituted in for f of negative 4 and what your process was. Then we have our x-intercepts. And our x-intercepts are where the function crosses the x-axis. And so my first x-intercept, 1, 2, 3, 4, 5, 6, about negative 7.5. And the next is negative 1.5 approximately, just estimating. And then we're going to the right, 1, 2, 3, 4, it's at 5. And those are my x-intercepts. Those are my x-intercepts. Now, number 7 and 8 introduce a new way to ask you something that we've already covered. F of x greater than 0. When you see f of x, think of y. Intervals where y is greater than 0. That's just a fancy way of saying, what are the positive, where is it positive? The intervals where the function is positive. It's a fancy way of just saying, where is this function positive? Where is the function negative? So 7 and 8 are asking, find the intervals where the function's positive and find the intervals where the function's negative. It's just asked a different way. So that's part of what you have to study when you go back for the quiz, which is on Tuesday, is when it's presented this way, what is it that we do? What does that mean? So for intervals where it's positive and negative, we use the x-intercepts. Oops. We use the x-intercepts and we use the boundaries. And so we already found we had negative 7.5 as the next intercept, negative 1.5 is the next intercept, and positive 5 is the next intercept. And then you need either end the boundary. So the far left, you're at negative 8, but that's open. And on the far right, you're at 6, and that's closed. We have another kind of unique thing, always trying to add layers, stretch you just to, here's one more thing that can happen. And so we're going to see that on 7 and 8. So that is negative when the function is below the x-axis. So it's negative on the interval from negative 8 to negative 7.5. It's negative on the interval from negative 1.5 to 5. So I'm just going to write, I'm going to just use a negative sign here, negative, rather than writing neg for negative. And on the other two intervals, the function's above. So here and here, the function is positive. Starts below, goes above, goes below, goes above. Negative, positive, negative, positive. So in number 7, the intervals where the function is positive. Well, that is from negative 7.5 to negative 1.5. And these are intervals, so we're going to use the union symbol. Then, and by the way, we have parentheses because at the x-intercepts, this function is not positive, it is not 0. 0, a height of 0 is not a positive or a negative number. So we never include x-intercepts when we are doing intervals of positive and negative. So when we get to the next one, starts at 5 and it goes to 6, but, and here is some new learning. At this point, when x is 6, is this function positive? When x is 6, is this function positive? Yes. Yes. And so it's ending a little unusually. It's not arrows. A lot of our examples, if not all of them, have it goes continuously up or down. So it was infinity and it didn't happen. But here this function ends on a positive note, right? It ends where it's positive, and so you need to actually include 6. You have to actually include 6. You have to actually include 6. Now, for intervals where it's negative, we start with this first interval from negative 8 to negative 7.5. What about this point? What about this starting point? Is the function negative at negative, where are we at? Negative 8. The function does not exist. It's an open circle. The function doesn't exist, so it isn't positive, negative, or 0. It's none of that because it doesn't happen. It's not there. Negative 8 is not in the domain for this function. Now, as you're going towards negative 8, negative 7.5 is, negative 7.5 is 0. Negative 7.8, negative 7.9, negative 7.99, for all those x values, the function is negative. But no matter what x value you pick between negative 7.9 and negative 8, if you pick a value, negative 7.99, that's not the smallest value where it's still negative. There's always another number in between that number and negative 8. So I can't put a specific value where it ends, where the function's negative. Negative 8 acts as a boundary, but we cannot include it because it's not even a value in the domain. So it starts from -8 and goes to -7.5. It's negative on that interval. And then union, it's negative 1.525. And those are parentheses. They're all, the -7.5, -1.5, and 5, those are all x-intercepts. And we'd always use parentheses on those. But, that -8's interest because it's something that we haven't really seen before. All right, on 9 and 10, for the max value, min value, I want y values only. I want y values only. So on number 9, there is a max value. The highest place that this hits is right here, and the y coordinate for that is 6. There's no other higher point anywhere on the graph. So there is a max value, and its value is 6. Okay, I will accept max value 6 when x equals -4. I'm okay with that. But if you write the ordered pair -4, 6, I'm counting it wrong. Min value. So as I am tracing this function, going down, 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 it's approaching this value of -4. So as we, if we think of how far it's going down, so this is going to its lowest point, because this only goes to, over here it only goes to -3. So as here we're going to its lowest point. If I say -3.9, that, because it's open, right, at -4, it doesn't actually hit -4. If I say -3.9, is that the lowest point on this graph? No, because there's -3.99. Okay, it's -3.99 is the lowest graph, or point, lowest y coordinate. Is that the lowest y coordinate? No, because there's -3.999. See how this game goes? Any value you pick between -3.99 and -4, there's going to be another number that is lower than it between it. There is no minimum. There's no min. Doesn't occur. Does not exist. Because there isn't a specific value that I can state that is the lowest, and there are no others that are lower than it. It doesn't happen. All right, so if we go to increasing, decreasing intervals, remember that you always use parentheses for increasing and decreasing. Always parentheses. The other thing is you are going to use the x coordinates of the relative max or mins. You use the places where the function changes from increasing to decreasing, decreasing to increasing, along with the far end ends. So over here we have -8, and over here we have 6. Doesn't matter, -8's not included, 6 is, because you're going to use parentheses anyway. You never use brackets on increasing, decreasing. And so always drive from left to right. So I'm going from the left, I'm going up, up, up. So I have an increasing interval, then down, 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 decreasing, and finally, whoops, back up, increasing. So it goes increase, decrease, and then increase. So my increasing intervals, -8 to -4, union 2 to 6. Always parentheses, never have to worry about brackets. Decreasing interval is just 1, it's -4 to 2. Any questions? And then domain, you're starting from -8, but it's open. You go to 6, but 6 is included. It's continuous. Every x is represented in between those. The range, it starts at -4. That's not included. It goes as high as 6 for the y's, and that is included. And there's your domain and range. You have 2 worksheets for your assignment. You have extra practice on difference quotient, and then you have the kitchen sink worksheet.